and welcome back to the Countering Climate Skepticism podcast, episode 2. Have you ever felt frustrated by the disinterest people seem to have in climate change? Maybe you have encountered people that downplay the seriousness of climate change, either online or in person. Have you heard people say, it's natural, or climate change has always happened, right? Like some kind of angry Brian Blessed. If you are anything like me, this can make you feel pretty helpless and demoralised. So this podcast is our attempt to help address this problem. We aim to provide the counter-arguments in the common climate skeptics playbook and give you the basic knowledge to counter all the bollocks arguments put forth by climate skeptics. My name is John, a history teacher, and with me is my co-host Mark, a climate researcher. How are you doing, Mark?
Not too bad at all, John. I'm very happy to be here. The fact that we're here for a second episode means that this podcast here is not just a flash in the pan like so many other podcasts that, you know, maybe do one episode and then evaporate out of existence. So well done, John.
Absolutely. Here's hoping we make it to 3.
Yes.
So have you had any encounters with climate skeptics or climate denial since we last spoke then, Mark?
Funny you should ask, John, because, I, unlike you, still go on Facebook. And on Facebook, there's this group that I frequent, and it's supposed to be, a discussion around climate science. But on that website, you get an abundance of deniers, skeptics who come out of the woodwork. Sometimes one even wonders if they're really real people or just bots. I don't know.
Yeah.
But yeah, so it's funny you should ask, because like last time, we were looking at, the skeptic argument that if half of 0.1% or not even half of 0.1% of the atmosphere is CO2, then surely that can't be doing anything in terms of warming the planet. So we dealt with this just last week in our first episode, and hey presto, there was a denier on that Facebook group using that exact same argument.
Nice.
It was a little.
You smashed his argument into the ground.
Yes, I didn't pull back. Let's just say that. His argument was a little bit more sophisticated. I think he was doing. He tried to make it a combo of 3 arguments. So it started off with, there's too little carbon dioxide in the atmosphere, and then he sort of said that, like, of the carbon dioxide that's currently in the atmosphere, the 420 parts per million, only 3% of that is man-made. And I'm like, no, it isn't. It's 33%. And I think then he finished on a point that's true. Basically, that carbon dioxide only absorbs. So if you think of like light as like a window, the carbon dioxide only absorbs in some parts of this window, so it doesn't absorb in all parts.
Okay.
So he was kind of like trying to say there's bugger all carbon dioxide. Only a little bit more has been put into the atmosphere, and it basically doesn't block out much anyway. Therefore, it's mathematically impossible for it to be doing anything.
Yeah. And
so I just got, busy on my keyboard and tried to cut him down to size. And I used the our cup of coffee that we so love, that revitalizes us in the morning. That's only 400 parts per million, and he did not like that.
Yeah,
John, he did not like that one bit. He was very enraged. Anyway, I soon retreated, and like a bunch of other people jumped on him. But yeah, so it's funny, just we were talking about it the other day, and it wasn't long before I encountered it in the wild. So there you go.
That's climate science 1, climate denial 0.
I hope.
So what have you got lined up for us today then, Mark?
So before I get onto that, John, I was just wondering, do you remember the denial ziggurat that I was talking about last week?
Yeah, I think so. Yeah.
Yeah. Do you remember the various levels, or?
I'm not sure if I remember all of them, but I remember that it outlines the various levels of denial arguments made by climate skeptics. So if I could remember correctly, the first level began with the idea that the Earth isn't being warmed, and then it moves up through various levels of denial. So if it is being warmed, it isn't man-made. And then, but if it is man-made, its impact might be limited. And then if its impact isn't limited, well, it might have some positive effects. And then right at the very top, I seem to remember, well, we can't do anything about it, so we just shouldn't. Is that about right?
You obviously were listening last time. Very, very good. You've got it mostly there. And the reason I asked is because, so today I'm hoping to look at the very first level that you mentioned. So the Earth is not warming. So that's the very sort of like, sort of head in the sand type of denial that you find. And actually, to be honest, like before I started like preparing for this episode here, I was sort of thinking, is this really necessary to do? Because surely this type of denial, I mean, it used to be more of a thing back in the day, but surely no one now is making the argument that the Earth isn't warming. It's just too obvious to everyone. And so, but in the course of making this episode, I've realized that it's not quite as dead as you might think. And the reason why I think this is because you've got this website called Skeptical Science, who've done an amazing job of like countering climate skepticism like we're doing. But they have this kind of list of denial arguments and how to rebut each of them at different sort of levels of complexity. But they have a total of, I think it's 219 different denial arguments.
Wow.
Exactly.
Well, at least that's 219 episodes that we can get in the bag then.
Certainly, yes. And even then there will be more. This won't be exhaustive because, I mean, I'm sure Piers Corbyn knows more than 1,000, but yes. Anyway, out of these, so I went through.
Sorry, just on that point. So I think we might have mentioned Piers Corbyn in the last episode, but I don't know if we clarified exactly why he's relevant to the debate on climate skepticism.
So Piers Corbyn. So he's Jeremy Corbyn's brother.
Right.
And he's, I guess, in the context of the UK, he's a sort of well-known climate denier, basically. I once met him at a sort of a research meeting, and so a lot of climate scientists were there to learn about climate models, and he was there as well because literally anyone could attend, and he just spent the whole meeting trying to disrupt things and asking silly questions, and so he's he's not very well regarded, let's put it that way.
What a waste of space. Yeah.
He could be using his talents elsewhere, let's just put it that way. So,
very diplomatic of you.
I mean, like, he's irritating, but yeah. Anyway, so what were you asking? You're asking about...
So what we've got lined up for this week, I think.
Yeah, okay, so so I had thought that the argument that the world isn't warming, or even that it's getting colder, would be boring, unnecessary, or supremely boneheaded. An argument to deal with, but it does seem like it's fairly it's still about. And there's also this kind of phenomenon you can encounter when dealing with skeptics. So they can bring up argument A, and you can then deal with that.
Yeah.
Then they bring up another argument B, and then you deal with that. And then once you've dealt with that, they bring up argument C, and then you deal with that.
Yeah.
And you can imagine how this goes on, until your patient runs out.
Right.
And then you just But essentially, it can be a bit like
just wear you down with bullshit. Yeah.
They can wear you down with bullshit. Yes. So one has to be a little bit careful, whether the person that's arguing with you, whether they're arguing in good faith, because it's not illegal to bring up many arguments, but some people are literally just trying to wear you out. But so this is kind of like a whack-a-mole thing. You deal with one argument, and then another one pops up, and then you deal with that one. And another way that I kind of sometimes think about it, with a gun, you have a chamber, like a revolver.
Yeah.
So you have like maybe 6 spaces for arguments, or for a chamber it's bullets. But as a metaphor or an analogy, I'm not entirely sure which one is appropriate here. Maybe our old English teacher can write in and tell us which one is which. But in any case, so you have these 6 chambers which signify like arguments, and you deal with argument 1, argument 2, you deal with that, argument 3, and then what happens once they finish argument 6 is they then jump back to argument 1, and you're like, hang on, we've already covered this exactly. So even if you're having some sort of other debate with a climate skeptic about whether or not it's economically worth dealing with climate change or something like that, you might find that suddenly there's the whole question about whether the Earth is actually warming comes up, and you're like, for fuck's sake,
We're back here again.
We're back here again. So
well, at least this will make it easier in future, because you'll just be able to go, I'm just going to refer you to episode 2 of our podcast.
Exactly. My thinking exactly, John. Definitely, yes. Do it once so you don't have to do it again. Yeah. Yes. So, right. So basically, we're going to do this. And let me tell you, John, if in case you don't listen to the rest of the episode, which you will, of course, because you're the host, you have no choice. But basically, in a nutshell, the conclusion is that, yes, it has been warming, and it will probably continue to do so.
So before we move on to the main topic then, Mark, I believe you wanted to comment on some feedback.
Yeah, sure. So I'll try and be quick, because I do have a tendency to waffle. So we are novice podcasters. We've just started. This is our first podcast. And so we gave the podcast out to several people to get some feedback. And some of the feedback was that I, in particular, was very long-winded. And we decided as a result of that to trim down our introduction, make it a lot shorter. But in the process of doing that, I feel like we cut something out, which perhaps felt it was worth saying. Basically, even though I've had many years of studying climate change, there is still a lot I don't know. And from time to time, I will say things and they will be wrong. But the way one can be so concerned with getting like everything right that one doesn't say anything at all, So I don't want to do that. So basically, I'm going to say what I think is true, and then if people who are listening to this show think there's a problem with what I've said, then they can write in, and then we will correct what I said if need be in the subsequent show.
Yeah.
So kind of,
as long as you're not a climate denier, in which case we'll ignore it.
Yes, that's true. Yes. But we're planning at the moment, at least, to record 4 episodes and then release them. So if you do have feedback, bear with us, because it might take a while for the feedback to come through. But anyhow, so there was one of my friends who's more scientifically minded. He made a very good point that he was slightly annoyed at something I'd said. Okay. And that was specifically that I think I said that CO2 was the most important greenhouse gas.
Okay.
And sorry, John, did I just to check here, did I explain what a greenhouse gas was, or explain much on that?
I don't specifically. I mean, I think my understanding is that it's a gas that acts as a layer that prevents UV light from escaping back out into space. Is that correct?
So it's almost correct. So it's a little bit more complicated than that, because basically UV is coming in, but what goes out then from the Earth is infrared. And so
okay. Right. Okay.
But essentially, for the purposes of what I was meaning to say there, I think you got it dead right. And the key thing is that some gases trap heat, others don't.
Okay.
So oxygen and nitrogen, which make up 99% of the atmosphere, they're not greenhouse gases, really. They don't really trap heat. But carbon dioxide is a greenhouse gas, and it does trap heat. So it's about the trapping heat or not trapping heat.
Okay.
Yeah. So I said, I think I said that CO2 is the biggest greenhouse gas.
Right.
And that's kind of a little bit incorrect, arguably.
Okay.
Because there is another greenhouse gas which has an even bigger effect.
Okay.
And that is water vapor.
Oh, right.
Yeah. So essentially, the water from the Earth's oceans gets evaporated, and then it's then called water vapor when it's in the Earth's atmosphere. And this it's a little bit different to carbon dioxide because it's not well mixed. So wherever you are on the planet, if you grab a handful of air, within it will be something like 400 to 440 parts per million CO2. So it doesn't really matter kind of where you are. This is going to be the same everywhere. But with water vapor, it can vary hugely.
Right.
Because, as you know, water falls out of the atmosphere.
Yes, it does.
In some places more than others.
Yeah.
But on average, if you take the average across the globe, water vapor it has a concentration of about 2,500 ppm parts per million. So that's getting on for 7 or 8 times the amount of carbon dioxide that there is. And so, did I completely get it wrong? Well, the answer to that is that the relationship between carbon dioxide and water vapor is kind of like that of a thermostat.
Right.
So if you were to take the amount of carbon dioxide if you were to take the carbon dioxide from the atmosphere and reduce it all the way down to 0, the atmosphere would cool as a result.
Yeah.
A cooler atmosphere can hold less water in it.
Right.
So the water vapor would condense out and it would rain back into the ocean. And because of this, the temperature would fall even further.
Yeah.
If, on the other hand, you increase the amount of carbon dioxide in the atmosphere, the Earth would warm, the atmosphere would warm a little bit, and because of that, it's a physical property of gases, basically, you will get more water vapor is able to be held by the atmosphere, which will then amplify the initial effect of that small increase in carbon dioxide.
So does that explain why, like in England, for example, that we're having a lot more humid, a lot more damper summers then?
I wouldn't like to comment specifically on that, but it could well be the case that that's related. Yes.
Okay.
Because with, I think it's something like, I'm just talking off the top of my head, but I think for every degree that the world warms, the atmosphere can hold something like 7% more water vapor.
Okay.
So there's going to be, basically the atmosphere as a whole is going to become moister with the increase in temperature. So that might be behind the observation that you've made.
Okay.
Yeah. So I said it's the biggest greenhouse gas. So water vapor does more of the work, but it is the carbon dioxide that controls the amount of water vapor that's there in the first place.
Yeah. Okay.
So does that make sense? Or
yeah,
a little bit?
Absolutely.
Right. So there is a common climate denial argument that centers around this, basically that water vapor, or H2O,
Right.
is so much more significant, so much more. There's maybe like 8 molecules of water vapor for every 1 of carbon dioxide. So because of this, they're like, well, carbon dioxide is insignificant, because water vapor is so much more prevalent in the atmosphere. Then okay, so if you do that, if they say this, then the way you would sort of then react is you'd say, well, what's causing the warming then that we've observed over the last 50 years or 100 years? Then they will basically say either they don't think the climate has warmed, and the rebuttals to this that you can give are the ones that we're going to be moving on to later in this episode.
Mm.
Or they will say that the climate has warmed, but that the cause of it is because of the increase in the amount of water vapor. Because, and this is true, the amount of water vapor in the atmosphere has probably increased over the where we've been increasing carbon dioxide. So then we might ask them, so what has caused the warming then? And then they will be compelled to come up with some other explanation. For example, the sun, because the sun is, quite it's a typical argument that a denier will use to explain why there's warming. So you have the amount of water vapors increasing. So and according to their logic, the temperature is going up because the amount of water vapor is increasing. But then you have to sort of say, well, what's causing the water vapor to increase? And then they might say something like the sun, although you could put in any different cause that they might invoke, volcanoes or whatever. But then you can then use other rebuttals to arguments like the sun. So this would be the second level of the ziggurat. So that the level where they think the climate is changing, but it's not mankind, it's some other cause that's causing it. So you could, for example, if they said the sun, you could say, well, the stratosphere, so the layer above the troposphere, which is the part of the atmosphere we live in, the stratosphere is cooling. The stratosphere wouldn't be cooling if it was the sun. So there's arguments like this, but go into now. In future episodes, we'll talk all about the kind of the second level of the ziggurat and the type of arguments. Here we're just focusing on the climate isn't even changing. This kind of flat out denial. It's not getting warmer or it's getting colder. So more on that in future episodes. Does that make sense, John?
Yeah, absolutely.
Great.
I guess next then, Mark, we're going to move on to the main part of the show. So I'll hand over to you.
Right. So first of all, John, a little question, a little hypothetical situation.
Okay.
If I was to give you godlike powers and you were able to move the Earth closer to the sun, what do you expect would happen?
Okay. Just thinking about what I might do with my godlike powers. But I guess,
John.
Okay, I'll keep focused on the question. I guess there'd be an increase in the intensity of UV rays. The planet's year would be shorter because we'd be orbiting the Earth, orbiting the sun quicker, and therefore there'd be shorter seasons as well. The temperatures would be hotter. Climates would become more extreme, particularly around the equator. Is there anything else I missed?
Yeah, that's not a bad answer. Some interesting things in there, definitely. Like I hadn't even thought about what might happen to the seasons, but yeah. So I mean, I could comment on some of that, but I guess in terms of like climate, I think you mentioned that temperatures would get hotter.
Hmm.
So temperatures of what would get hotter?
Well, I presume the just the air temperature, I presume.
Yeah. So definitely, one would presume that the air temperature would increase.
Oh, and I guess maybe the water temperature as well. So
Yes,
oceans and seas.
correct. Yeah. So I guess when we're talking about like the climate has warmed by 1.1 degrees since 1850
Mm.
or something like that. What we're kind of talking about there is the average surface air temperature.
Mm.
And so this air temperature is measured, I think, between 1.5 meters off the ground and 2 meters off the ground. So it's
Okay.
kind of like where your head is, essentially. But yeah, you're right. There's also the ocean temperatures as well. Okay, so what do you think would happen to the ice?
It would melt, and then that would cause sea levels to rise.
Correct. That's what I was looking for. And so, what ice might we be most scared about melting?
When we were over in the States, one of the most dangerous mountains at the moment on the west coast, which is part of the volcanic rim, the
Yeah.
Ring of Fire going around the Pacific, is Mount Rainier. I like to say Mount Rainier because it's the same surname as me, no relation. But that's considered one of the most dangerous mountains or volcanoes in the Pacific Rim because it has a high degree of glacier ice, and the consequences of a volcanic eruption would be that it would cause all of that superheated glacier ice to melt, and then would cause massive flows down from the mountain, having big impacts on human settlements nearby. So I'm presuming is it mountain snow and ice on mountains that would be the most dangerous?
So I suppose in relation to like the people who live in the vicinity of Mount Rainier, was it?
Yeah.
I guess, yeah, certainly for them, the most dangerous ice to melt would be the ice, what we know as glaciers. So there's the ice that's on top of mountains. But in terms of sea level rise, it's probably not that significant.
Okay.
In fact, you could take probably all the glaciers across all the mountains across the whole world, and I don't have the figures to hand, but I don't think they would cause that much of a noticeable rise in sea level. But there are other sorts of ice in the world that would. And so I was just wondering, do you have any idea?
Would it maybe be the Antarctic permafrost then?
So in Antarctica, I don't think they have permafrost. So I think permafrost is. So when I think of permafrost, I tend to think of the sort of the northern hemisphere, the northern bit of Russia, and so basically you have soil, and underneath this soil there's groundwater. I might be getting this a little bit wrong, but essentially you have like frozen water underneath the ground. So you'd be walking along the top of it, and it would be like soil, presumably. You might even have trees growing out of it, but there's ice there that could melt, and that's permafrost. So Antarctica, you don't have permafrost because it's just kind of ice. But you're right that a lot of the ice in Antarctica, there's a lot of ice there, and if that would all melt, I think it would, which is not we don't think that's likely to happen. But just say in some god awful situation, all of it melted all at once, global sea levels would rise by something like 60 meters.
Wow.
Which would be horrendous.
No more Netherlands. Yeah.
No. The Netherlands is well and truly gone. Well before 60 meters. Yeah, yeah. So that's the biggest source of ice that could contribute to sea level rise. But there's a second contender, and any idea where that might be?
I presume then the Arctic.
Yes. So Greenland.
Okay.
So Greenland is like a sort of an island essentially, and on top of it, it's got this huge lump of ice. And I can't quite remember how thick it is, but it's a lot of ice, and Greenland I think has something like 7 meters worth of sea level of ice. If that all melted, then sea level would rise by 7 meters. The Arctic itself has a lot of sea ice, and sea ice is very important. But even if all the sea ice melts, it won't add to sea level. And the reason for that is, if you can imagine, I don't know if this analogy quite holds, but if you have like an alcoholic drink, like a gin and tonic, and you have an ice cube in there in the water,
the water displacement cancels each other out, does it?
Exactly. Yes. So yeah. Sorry, that was a bit of a tangent, but essentially, I think So there's a lot of, if we move the Earth towards the sun, a lot of ice would melt, basically.
Right. So what sort of things do the climate skeptics and denialists and contrarians, what do they say in relation to this?
Right. Okay. So there are many things that they say. It's quite. So again, from Skeptical Science, I came up with 35 out of 209 or 219 arguments there were related to the Earth is not warming or the Earth is cooling down. And so I went through them all and I kind of categorized them into different types of arguments, and I came up with like 5 subtypes, well actually 6 subtypes.
Okay.
So the first one was just flat out denial. There's been no change. It's cooling, and it had 9 of those. The second subtype was we just don't know. We don't have the data, or our data is poor quality.
Right.
5 of those. There's one type number 3, which was it has since. So it was warming, granted, but it stopped warming a while ago.
Right.
4 of those. There's the type of argument for number 4. Some places or some years are cooler than they were on average. Therefore, this disproves the climate is warming.
Right.
So 4 of those. Did you understand that one, or do you want me to go over it?
Yeah, I guess so. I mean, I that's like we talked about last week when we talked about the idea of climate being a measure over time rather than just a snapshot.
Correct, yeah. And then, so the 2 final ones, subtype 5 and subtype 6 were misleading arguments. And then the final type were just flat out factually incorrect.
Right.
So there's a fair amount to go through there. So what I did is I selected out like a few characteristic arguments.
Okay. And
then what we can do is we can sort of look at the argument and then go to the data. So if, for example, if someone says the Earth hasn't warmed, then the way to sort of deal with that is to look at, well, what does the data say?
Okay.
And so that's what we'll do. Just for anyone who wants to, so I guess this will be a lot of like John and I looking at different figures that we can both see. So I encourage anyone who's interested to look at our PowerPoint with all these different figures, and we'll put it in the show notes if you want to study yourself. Okay, so here's I think there's about 8 I ended up hand picking. So the first one from the the subtype of flat out denial, or it's cooling, there's no change. An example might be, like literally like the subtype says, the climate is not warming, or it's even cooling. And so if we look at slide 4, and John, tell me what you see in the upper graph.
So we've got years along the bottom, so it covers the years 1850 through to just beyond 2000, and it is showing us how temperatures have increased faster over land than over the oceans. So it shows 2 lines. We've got a red line showing the temperatures of land, and oceans showing the temperatures in blue, and it shows that there's been an increase since 1850 in the oceans of 0.88 degrees, and in land 1.59 degrees.
Brilliant. Very expertly explained. I'm sure anyone listening at home will have quite a vivid picture based on that. Yes, so I don't really think there's that much that I can add. But I mean, like, just looking at this, John, would you say the temperatures are going down, or are they flat?
I mean, it very clearly shows that, like we've seen with, like, when you look at population graphs since the industrial period begins, that you see this kind of exponential increase over the course of the 20th century in population, and it's showing a very similar kind of pattern when it comes to the temperatures here. So we're seeing that it kind of stays relatively stable across the 1800s, but as soon as we hit 1900, that increase increases, and then since probably about 1960, 1970, then it starts to much more rapidly increase.
Yes, well explained. I just hope that the temperature rise isn't exponential, because that would not be fun. But yeah, certainly you can see that temperatures have gone up. And if you look to the figure below, so the figure below that one, you can see that. So there's 2 panels, and if you look at the top one, you can see that there's like 4 different temperature series, and they're sort of written above the graph. So you've got, I'm probably going to mispronounce this, but Hadkrut 5.0. So these are basically 4 different centers across the world. Hadkrut is my old University of East Anglia, and they have all independently attempted to produce temperature records over this period. And so when you put them all together, you see that there's a good, not perfect, but there's a good agreement between the 4 different data sets.
And it's quite interesting where it varies, because I presume the wider the gap is, it's the more variance they have in whether they agree or not. And it seems like the biggest variance is around the 1940s, the 1950s.
Yes, so you're talking about that spike above 1940. Yeah, so the thing about climate is that different things do impact upon it, and so it's not merely like we're saying carbon dioxide is the only thing that influences climate. Mm-hmm. So for example, you can get sort of volcanoes, pretty big volcanic eruptions that go off, and that can lead to a temporary cooling of the climate if the volcano is big enough. Okay. Another thing that's quite perhaps relevant for this temperature series here is that when we burn coal, we typically produce a lot of pollution. And one of the funny things about the soot or the sulfur dioxide that we produce from this pollution is that it actually kind of reflects away sunlight.
Okay.
So you've got this funny thing going on, perhaps, whereby if you burn a lot of coal, ultimately it will mean that the temperatures on planet Earth go up. But locally, where you're producing all of that soot, you might actually be getting a cooling effect.
Right.
And so for example, like I think one of the things that skeptics like to leap on in this temperature time series is if you look between 1940 and 1970.
Yeah, there's a dip. Yeah.
Yeah, or at the very least, it's kind of like flat. You know, there's a bit of variability, but you could argue that it's nothing changed for 30 years. And so this could have been to do with the fact that the amount of soot we were producing was larger, was the effect of that was swamping the effect of the CO2.
Right.
But so eventually, like as we burn coal, we got cleaner coal to burn. So we produce less and less soot.
Yeah.
But we keep burning more coal. And so then ultimately maybe what happened is the carbon dioxide effect won out again by about the 1970s. So essentially there are many things that can impact a temperature record like this. But so the other thing to mention is that you also get something called internal variability in the climate system. So have you heard of a phenomenon called El Nino?
Yeah, I think we mentioned it last week. Yeah.
Yeah. What do you remember about it, or anything at all? Or?
That it's a cycle between El Nino and La Nina cycles of above average temperatures and below average temperatures. Is it something to do with the Pacific weather systems causing a change in temperature?
Yes, yeah, that's not a bad explanation at all. Yeah, so you're right. So it's essentially that there are some years where a particular part of the equatorial Pacific Ocean, it's the sea surface, is a lot warmer than average, and that's called an El Nino. And then on other years, that particular part of the ocean is colder than average. And on El Nino years, you find that the Earth is a lot warmer than it would be on average. And in La Nina, we kind of get a little bit of a cooler Earth. And so this happens 3 to 7 years. It's not regular, but it means that you get this kind of variability within the climate system. So even if there is this longer term carbon dioxide effect, from year to year, you can go down, you can go up. But if you look at the big picture, you zoom out, you can see that, that this is the bigger thing overall. But yeah, so there's a lot in that time series of temperatures. So, but yeah, so that's some background. So if I move with you to slide 3.
Okay.
So this is the same graph. Also, so maybe you could describe it a little bit.
So which one have we got here? Is this the 12 KY temp, is it?
Yeah.
Okay. Right. So this one, it looks like it's a graph breaking down human history, going down along the bottom from 10,000 BC all the way up to 2000 AD or CE, the Christian era. And it kind of splits it up into 3 phases. So it looks at the global surface temperature in kind of prehistoric times. So up until the medieval period, I think we're looking there around the year 1000 AD. And it looks like there's this gradual, significant increase in global temperature and then decrease again. So that looks like what might be maybe a natural rise and fall in global surface temperature. Then we see, but obviously that's a very condensed period of time. So that's like 11,000 years where we're seeing this rise and fall. Then it kind of flatlines, maybe gradually gets a little bit colder between 1000 AD through to 1800, which, you know, being a history teacher, I know coincides with what was known as the mini ice age. If you see any kind of Victorian pictures of London, and you'll see people doing ice skating on the Thames and things like that, because it used to freeze over in the winter. And then from 1900, we can see under the industrial era that it increases again. And this graph is showing that over the last 50 years, global temperatures have increased at a rate unprecedented in at least the last 2,000 years.
Very well explained, John. That's I don't think really there's much I can add. I guess I just wanted to show this graph just in case people were interested in what was the temperature like prior to 1850, which is where we typically start from. I guess if you can go back to slide 2, the slide before that, and you have basically it goes back even further. And so here you're going back to the 60 million years ago. So if anyone's just interested in what temperature was doing over that period, you can see in this graph in figure 2.
So we're seeing that like around the time of the end of the dinosaurs, that things were significantly warmer. And I presume, like, because when we're looking at about 60,000 or 60 million years ago there, the fact that it's increasing again, I guess that's the impact of the meteor that wiped out the dinosaurs that led to a very quickly cooling planet, I presume.
So you're asking, why was it so damn hot at the time of the dinosaurs?
Well, we can see here it's hot at the time of the dinosaurs, but actually after they go extinct, it increases even more. So I presume that dip is actually showing that's the point when the meteor had hit and the temperature had dipped, and then it's increasing again after that as the planet recovers from the meteor.
So this is where I think my expertise runs out. I mean, I think it was 65 million years ago that the dinosaurs went extinct. So it will be slightly before the beginning of this graph.
Okay, yeah.
But that's a very interesting question, actually. Like, what did I mean, what happened to global temperatures after before and after the meteor hit? Maybe someone will know more about that. If you do, please email in. We'd love to hear about that. That sounds like a very interesting topic. I'm not too sure, to be honest, why it was much hotter. I mean, like the sort of, when I've looked at these sorts of things before, you've had situations where you might have had like, the Earth might have been in a state where there was like literally no ice, in it at all. So there would be no ice at Antarctica, no ice in Greenland. The continents would have looked very different. But yeah, it was very, very different climate back then, and one that the dinosaurs were used to until, presumably it sounds like they're fairly certain now that it was a meteor that came and wiped them all out, and that probably caused havoc with the climate, and led to their extinction. So that's the last, just in case anyone's interested in like how this all fits in with previous climates. I guess the thing to stress again is that it's not so much Earth has been much hotter before, but it's not necessarily the absolute temperature that makes us so concerned with climate change and global warming right now. It's the rate of change. I mean, just to point this out, if you look, do you see, so 60 million years ago, you have like, I don't know if you can see it. It's like this red spike just before you get to the peak.
Yeah.
So, hang on, have I got this right?
Maybe it just shoots up. So for our listeners, what we're seeing here is that 60 million years ago, the temperature of the Earth was looking to be about 10 degrees warmer than it is today. And that actually it increased all the way up to beyond 20, just all of a sudden for one very brief period.
Yes. So that event is something I studied briefly at university, and it's called the PTM.
Okay.
And it's a bit mysterious as to why it happened, but essentially you had this enormous change in the climate very suddenly. And now you can see on the graph, it's just like this instantaneous spike, and then it comes back down again. So what I do remember about the PTM was that even though it was like very, very fast on a geological timescale, it was something like still something like 40 times slower than the rate at which we're currently changing the climate now.
Right. Yeah. Yeah.
So that was a bit of an eye opener. We're really causing some changes. Okay. So right, next argument: sea level is not rising. Is sea level really not rising? Let's take a look. Can I get you to move to slide 16, John? So here you've got like 4 graphs. Can I get you to first describe what's going on in the bottom left graph?
Oh, bloody hell, complicated one. Things are getting worse. That's what I can work out. Okay, again, it's showing 1850 till now. And it's the global mean, so the global average sea level in meters.
Mm-hmm.
And it's gone from what's considered 0 to plus 0.25 pretty much by now. So an increase of a quarter of a meter.
Correct. Yeah, that's absolutely what it shows. And I guess it's you've got various different people with their sea level reconstructions. So essentially, it's like across the world, you've got different research groups trying to figure out what sea level was like at different points in the past. And so they work out independently what they think it is, and then they put them together, and you see that you get a fair amount of agreement, but not perfect agreement. But,
and obviously those have such a dramatic impact on low-lying communities and things like that, don't they? I mean, I've been seeing recently that like Pacific Island nations and those that are based on like atolls, like I was doing some reading on this earlier this week, like kind of islands that are in a kind of circular shape or a semicircular shape that have a lot of reefs. They are almost completely disappearing when there's even a slight increase in sea level.
Yeah, it's really, really sad. It's yeah. I mean, it's I guess the sea level rise is kind of like an average phenomenon, but you can get like variations in the phases of the moon. So if you have like a spring tide, the sea level will be higher than usual. And then when you get a neap tide, the moon lines up with the earth and the sun in such a way that sea level is lower than average. So you get this kind of like monthly oscillation in the height of the sea level in particular places. But of course that comes onto an average. So if you have 150 years ago, if you had a spring tide, you might be, I don't know exactly, but it might be the case now that if you have just a normal tide, that would be equivalent to a spring tide back in 1850. Now, if you get a spring tide on top of the 25 centimeter rise, it's going to be super spring tide compared to spring tide at the. So the way I've seen like different people, they might be all right for like part of the lunar cycle, but as soon as it starts to be spring tide, then they just get menaced by the water.
Yeah.
So
and even in Wales, someone sent me a video the other week of a car park in Wales by the coast, and it was just absolutely being battered by waves from the sea. There were cars, even like vans, being like thrown around by the waves. Was
that during a storm or something? Or
yeah, it was, but I think it was something that had never been seen before.
Damn.
If I find it, I'll put it in the show notes.
Yeah, sounds horrific.
Watch some teenagers being taken out by waves. It's quite funny. It's quite a funny thing to watch.
John, I know you're a teacher and you may harbour animosity towards certain.
Nah, of course not.
No. All right. So not related at all to finding it amusing, teenagers. So does it look like sea level is not rising, John?
No, it looks the opposite.
Yeah. So essentially, I guess one of the annoying things is like, someone can say whatever they like, and it takes a couple of seconds to say sea level's not rising or the temperature's not changing. And if you don't have to your hand the data that shows that it is, then like it sometimes it's a bit difficult to counter them, like at that moment.
So you're recommending carrying these diagrams around with you at all times in case you come across any climate skeptics, just like, oh, we'll have a piece of this.
That's exactly what I'm recommending, John. I guess it's more that you can spot bollocks when you see it. So when someone says they're not, you can say, well, actually, if you go and look at the data, which is what, any Tom, Dick, and Harry can't have an opinion about this sort of thing. Like you have to look at who's in a position to know, and you can direct them.
If there's anything you can take away from this podcast, it's that we teach you how to spot bollocks.
Yes, but there is an awful lot to spot, so it's no mean feat, and it keeps reinventing itself in different shades and variations on bollocks. It's just never-ending bollocks.
Bollocks everywhere. Yeah.
So before we go, did you mention that you had another positive climate news story without the hopium?
Yeah. I have. I've found an article this week about the state of Montana over in the States, up in the north. 16 young people aged 5 to 22 have, over the last couple of weeks, won a legal case arguing that the state of Montana had violated their constitutional rights by promoting fossil fuels. This is really, really exciting. Like being a teacher myself, it's great when you see just like young people getting stuck in. It's awesome the things that they can achieve. And so, to give a bit of context, Montana is a major coal and gas producing state.
Yep.
And this court case ruled that a stable climate is included in your right to a clean and healthy environment, which is one of the stipulations for state laws. Mm-hmm. And so it also overruled a clause in Montana that said when introducing new coal or gas or any kind of oil things in the state, there was a clause that said that climate impact did not need to be taken into consideration. And this ruling overrules that.
Right.
So, this really is the beginning of quite a game changer when it comes to like climate change in the law, because it showed that trials can make a difference. They do change things. And because this one has been successful, that's going to go on to get the ball rolling and encourage other states and other countries to do the same, to try and kind of push these things through the courts. It's also great for the climate scientists as well, because the court rulings are affirming climate science. They are basically just saying, yep, this science stands up, and we are now building that into our legal outcomes as well. And it seems like the defense case was a bit haphazard. They were not referencing anything of kind of thorough science to back up what they were saying, but what they didn't actually bother to do in their defense is argue against the existence of climate change, or, and this is a critical one, or that climate change was not human caused. Which really is significant, basically saying that they knew that their defense would not stand up in court if they used the argument that climate change isn't happening, or it wasn't us that's done it. So that really is quite a game changer, and it basically kind of reinforces the idea that climate denier cases are just being thrown out of court now. There have been some cases that have attempted to go through where the judge has thrown it out of court before it's even got to trial, because they're basically just saying there's no evidence that climate denying can be something that we can take a legal action against, which is really reassuring.
That's good. I really, one wonders. I'm not an expert on American politics, on the judiciary in America by any stretch of the imagination. But I just wonder, is this going to be, if this sort of positive change, say for example that Trump gets in at the next election in the US, which is not impossible. Trump is climate skeptical, to say the least. I just hope that these sorts of changes are sort of, I guess, immune to whoever's in power. So I hope that a change of government doesn't mean then that suddenly these things get overruled back, if you see what I mean.
Well, one of the major things about American government is that state law is separate to federal law,
yes.
And they are fiercely protective of infringements at the federal level on state law. So that's a positive in favour. It also means that if you want to have changes happen across the country that aren't introduced at the federal level, it means they have to happen 50 times in order to go through every single state. The other side of things, and this is something that I'm not completely sure on, I don't know if it only applies to the Supreme Court at the federal level or if it affects state courts as well, but they have a system of precedent, which basically means that in order to pass a new ruling in favour of an issue that has been debated or gone through the courts previously, they have to look at the outcomes of previous court cases, which then informs the decision for future cases. So, for example, like on a completely separate issue, but everything that's been going through the courts about abortion rights in the States, Roe versus Wade, which was that massively important ruling at the federal level that basically said that it was women's right to be able to access abortion. That it was so important because it also became what all subsequent laws were referred back to. And it's only really been because of this catastrophic ruling by the Supreme Court recently that's overruled that. I don't know if the same system applies at state level. If it does, it means that any attempts to try and rule the opposite direction have to look back to that case that's just gone through and see what was done there, which could be really good if that is the case. But I don't know how all that works. But
Well, maybe if any of our viewers are from the US and they're more au fait with the ins and outs of the federal and what's the other one, the regional state level, then maybe they can tell us, where we're what you were not sure about.
Yeah, absolutely. Okay, so I think that pretty much has us it for today with our with what we were going to be covering. So to wrap things up then, that's it for this week, and thank you very much for listening. You can find a link to all of the materials we've referenced in this episode in our show notes. We will be back next week with the second half of this episode, where we're going to continue to myth bust the remaining arguments claiming that global warming is not happening. If you want to know more about countering climate skepticism, check out our website at
ccspod.podbean.com. So that's ccspod.podbean.com.
If you've enjoyed the episode and would like to support the show further, you can leave us a review on iTunes or Apple Podcasts, as it's now known, or support us at Patreon at Countering Climate Skepticism. That's skepticism spelt with a K instead of a C. So that's it from me. Goodbye from me, John Rainier.
And goodbye from me, Mark Prosser.
Thanks, Mark. So we look forward to seeing you next week. And I'm going to leave you with the words of Barack Obama. We are the first generation to feel the impact of climate change and the last generation that can do something about it. Thank you very much. See you next week.